Net to dev.
How can we set up a Soroban environment that will allow us to write the smart contracts, test the smart contracts, compile to ultimately deploy the smart contracts? How can we interact with the Soroban testnet or the main? How can we request test tokens? How can we create an account that will be used to deploy the smart contract? Similar to what we do with EVM-based blockchain, which means that I have to create an account in the Soroban testnet. I have to fund that account, because we need to have test tokens in order for us to deploy the smart contract and pay the transaction. And we also have to work with the Soroban environment. We have to set up a local environment that will allow us to build that Rust smart contract, compile the smart contract to ultimately send that to the blockchain, deploy that on the testnet. How can we start interacting with that smart contract? How can I send calls to read the smart contract, to pull data? How can I write to that smart contract? We need to also know how can we build JavaScript functions that will allow me to connect and make those calls. We have to present those functions in the environment, and we have to point those functions into an RPC. We have to provide the RPC path or the RPC address that I will be sending those calls. All of that. With that said, let's go ahead and let's get this party going. Okay, now let's start by installing all the Rust Toolchain component. With this, I can develop the Soroban smart contract in the workstation. Okay, so on my machine, I can develop the Soroban smart contracts. I can also deploy the smart contracts. I can interact with the testnet and so on. So the first thing I'm going to do, I am going to head to the developers section of Stellar site. Okay, this will be developers.stellar.org. Then we will head over the getting started and we will click setup. Okay, let's go ahead and do all this. We are going to be setting up the environment. We are going to build that wallet. We will generate that account, aka the wallet, and we will fund that wallet, deploy a smart contract, and you will see everything. And once we're done with that, we are going to be writing JavaScript functions that will allow me to interact also with that RPC, with the RPC that connects to the testnet, so then we can interact with the smart contract. What better use case than when we deploy a decentralized application and we need to make calls into that smart contract directly from a front end? First things first, let's head under developers.stellar.org and let's hit on setup. Let's start, okay? I am going to be using a Linux machine, okay? I believe that the Rust Toolchain works best on Linux and Mac OS, but you still can do it on Windows, okay? So what I'm going to do, I'm going to open an Ubuntu server, so I'm going to be working with this machine right here, okay? So the first thing that we have to do, very common, apt-get update, okay? Make sure that the machine is up to date, and apt-get upgrade, okay? So in my case, I already did it, but make sure that you run those two commands, have everything up to date, and then we are going to start. If we go back to the site, we are going to see the first command. This will allow me to install the Rust environment, okay? So I'm going to copy this, or you can just click here, then go back. I'm gonna go ahead and paste. So now it's asking me, what do I want to do? I want to proceed with the standard installation, okay? So I'm gonna press enter, and we will let everything do its magic, okay? Awesome, we are done. So let me go ahead, and it's asking me to restart the shell. I'm just gonna do a reboot. Let's go ahead and install the target. Okay, so we are going to be compiling the smart contract into WASM32. I need to install also this dependency so that I can perform that. Since I install updates, it's good to have a fresh restart, okay? Okay, we are back online. Okay, awesome. So let me see if I have Rust up. Sure, I do. Awesome. Gonna install WASM32. So once we are ready to compile the smart contract, it will be compiled into WASM32. We will then use that file that gets generated and deploy that into the Soroban testnet. Okay, go back. Wait for this. This is done. Awesome. Now let's see what else do we need. Okay, we are going to be installing the Soroban CLI. This is the command line interface that allows me to interact with the SDK. Okay, so let me do cargo install locked Soroban CLI. I'm just gonna copy this. Let's go back. There's one dependency that we have to install in order for us to install the Soroban CLI, and that is the essentials. So I am going to run this. You should also install this at the beginning when you first initialize your Ubuntu machine. Okay, so first create an Ubuntu machine if you're running a virtual environment, and then run apt-get update. apt get upgrade, and then apt install build essentials. Okay, let me show you. Okay, we are going to install apt install build essentials. Let's install that. Else, if you don't install this, when you try to install the Soroban CLI, it's going to fail because it's looking for a particular dependency, and I believe this package has that dependency. Okay, so you make sure that you install that first. Now let's give it a shot. Look at that. Okay, awesome. So we are definitely cooking. Okay, cool. So now I should have access to that CLI. So let me type Soroban. Woohoo! Awesome. So we got the CLI installed. Okay, next thing. And now we are going to be adding a pointer to the Soroban testnet. So basically, we are going to be adding an RPC pointer that will allow us to interact with the testnet. If we are working with macOS or Linux, we are going to be using this particular syntax. Okay, so we're going to copy that. Let's go ahead and add it. So you can see, boom, it has been added. So we copy and paste. And now if we add that, by the way, I can go ahead and show you what happened. Okay, so we typed Soroban, then network add, then we provided the parameter of a global, testnet as parameter, then RPC URL, then the URL for the public Soroban testnet RPC address, and this will be what is expected to provide this test FDF network string. I believe the next item is to create the identity. This is the account that I'm going to save on the environment so I can use it to deploy the smart contracts. So you can basically create the account and store that in an identity. It's called an identity that you can just call whenever you are going to be interacting with the testnet. Okay, so let me go ahead and grab this, right? But we are going to be a little bit creative. We're going to change this to be net to dev. Okay, back into my machine, and I'm going to say net to dev. And you can see here, network testnet, right? That is the name that we passed initially when we store this value. So what we are effectively doing is we are calling that network testnet, which we add before. We added this entry before. Now we are going to be using that. So let's say you want to store another entry that is not this particular URL, then you can just name this something else, and now you can invoke that here, okay? So let's go ahead and enter. And what's going to happen is we will obtain the identity address or the account address. And also, the moment we type Soroban keys generate and we've specified the network and the name of the identity, then we will also obtain faucet tokens. So with those tokens, the account has been officially initialized in the testnet, right? If we generate an account, but we haven't funded the account, we are not going to see that account live on the testnet, okay? And the same goes for the mainnet. So make sure that by default, it's going to auto request those test tokens, the test XLM tokens, and then from there we can do whatever we want to. If we generate a new account, we don't fund the account, it's not going to be active on the testnet, okay? Awesome. So now I wonder what the address of that account is going to be. So let's take a look and see. Now we can see the public key of the account, which is, the account address, okay? So I'm going to say Soroban keys address, and obviously we got to change to net to dev, okay? I'm going to say, instead of Alice, we're going to say net to dev. And that is our identity or our account. This is the account. So if I copy this value, and let me head to a block explorer. When we open this particular explorer, we can swap ourselves to a testnet, right? And now I am going to be pasting that value that we generated, okay? And sure enough, so now you can see that I have a testnet account, and then it has 10,000 test XLM tokens. Okay, now this account is ready to go. Now let's head back, and now let's create the first smart contract now using the environment. We are going to create the smart contract, and we will compile and deploy the smart contract using the environment. We are going to be setting up this new project. So the cool thing about this is that when we initialize any project, when we pass this command right here, we are going to be initializing a new project that is going to include this folder structure. This is the project structure, which includes some files in the root of the project, then a folder called Hello World in this case, and then the cargo tom and source. Inside here is where we have both the lib, which is the contract itself, and a test to the contract, okay? So let's go ahead and do it. I'm gonna copy this, I'm gonna go back, I'm gonna go ahead and deploy this, okay? Now list, and now we have that folder called Soroban Hello World. Navigate to that folder, clear, let me ls. Now we have the files and we have the contracts folder, and that should match the structure that we saw in the page. Okay, so you can see here contracts. Those are the files that I have in the root, and then I will have another folder called Hello World and all that. Now let's go ahead and open this folder in Virtual Studio Code, and let's continue. So the first thing that we need to understand is when we work with the Soroban environment, we are going to have a workspace file. Basically, this is what tells the environment what am I going to be importing or what am I going to be using on this particular environment as far as the dependencies. If you come from a JavaScript background, this is very similar to the package.json. It's basically a way for me to tell the environment what dependencies I'm going to be using, etc. Okay. Now the next step, let's take a look and see the contract. So let's open that contracts folder. And now we have another cargo. Okay. So this cargo is related to the project, the contract itself that we're writing. Okay. It has the crate that has been imported, which is cdylib. This is the crate that allows me to build that smart contract. Once we write it, once we go ahead and compile, this is what it's going to build. And obviously it's telling me, hey, am I going to be using that Soroban SDK from the workspace then through? Yes, I am going to be importing that because I am going to be using that. Now with the package, under the package, I can define the name of the project or the contract that I'm trying to build, what the version is. This is up to us developers, the edition, and if we're going to be publishing this smart contract. Now it's what we did on the previous video with okashi.dev. Now we can do it in Visual Studio Code, okay? So we're gonna head to the source folder, and this, ladies and gentlemen, is going to be the smart contract. Same way as we did on the previous video. We have the first statement. We're not going to be using anything from the standard Rust library. Everything has to be invoked from the Soroban SDK. From the Soroban SDK crate, we can then import the types, macros, everything, okay? So with that said, we now have the smart contract. This is a very basic Hello World smart contract. What it does, as we know, is a public function named hello, and then imports the environment. Then we are going to be passing a string, or in this case will be a symbol, and we are going to be returning a VEC type. VEC is an array. Right here, this is literally an array, okay? So it's an array that has two values. Basically, it's going to say hello, and then the name, or in this case, the value that I'm going to be passing externally, okay? Once we deploy this, then we also have a modifier called test. What this is going to do tells Rust to run the test, and what it's looking for is that test Rust file, okay? So this right here is a test that I'm going to be executing to confirm that the smart contract runs the function as expected and there's no errors, okay? So let's go ahead and let's continue. I am pretty sure that what we're going to do now, we are going to be running, executing this. We are going to be compiling and deploying it, okay? So let's go ahead and do that. So now what we need to do is we are going to be invoking that test, and we will make sure that the smart contract is ready to be deployed. What we need to pass is going to be cargo test. I'm just going to copy it. Okay, let me go and navigate to the contracts folder. And now let's go under Hello World. Let me go ahead and head to source. Cool. Now let me go ahead and type that cargo test. Okay, so let's go ahead and do that. Okie dokie. And everything looks to be successful. Everything looks good. Okay, cool. Perfect. All right, next step. Now we are ready to build that smart contract. So let me go ahead and copy it. Basically what it's going to do, I'm going to invoke the Soroban CLI contract build. As we can see here in the documentation, that when we initialize this contract build, what happens in the back, it's cargo build, then target, and this will be the compiler. Okay, this will be the byte code that we will be using to compile the smart contract. Okay, right? So let me go ahead and do that. Okay, so we have to be in the folder where that cargo workspace is located. Okay, so let's go ahead and run that now again. And there we go. Okay, woo, awesome. Okay, we're done. Now we can see here that it says compiling. Now it's compiling that Hello World smart contract, and we are finished, released, optimized target in 30 seconds. So let me clear and let's see. Okay, it built that target with basically it's the smart contract compile. And we can see here, if we navigate to target, then under target, we navigate to WASM32, then we should have that ready to go here. And the smart contract is here. And now it's in WASM format. I am pretty sure that we can deploy this because this is the file that is already compiled. Now we can just send that and deploy this onto the blockchain, okay? First things first, I believe there's one last step that we have to do, which is the optimizations, okay? So we have to optimize the bill. It's a way for me to optimize the calls to make it as efficient as possible as far as the cost, okay, the transaction. That doesn't mean that I have to do it with any smart contract that I deploy, right? But if the smart contract involves a lot of calls that will involve a lot of transaction fees, then you want to make sure that you optimize the code so then it's more efficient, okay? So now let's do this. I am going to, first of all, I have to install that optimizer, okay? So we have to install that optimizer. So I'm going to go ahead with cargo, once again, install the optimizer. Okay, and we are done. So now, next item, let's optimize the smart contract. Okay, so I'm going to copy this right here that says Soroban contract optimize. Then we are pointing to that WASM file, the hello world. Okay, so I'm going to copy that back into the root. And I believe under the Soroban hello world, this will be the root of the project. Then we can go ahead and optimize because it's going to look for that target folder. Okay, and there you go. So we have optimized the smart contract. Next thing. We are ready to go ahead and deploy to the testnet. Okay, so let's go ahead and do that. Using the Soroban CLI, all I have to invoke, it's going to be contract deploy. Then we point to that WASM file, the one that we compile. Then we will source to the identity that we want to use to deploy the smart contract. In this case, my account, the account that has been funded, okay? And then specify the network, testnet, okay? So in my case, I'm gonna copy this, but we have to modify this right here, okay? I'm gonna go back here and change this to net to def, okay? And that should be it. So let's go ahead and do that. Ooh, what do we have here? Awesome. So we have the smart contract address, okay? This is our first Soroban smart contract deployed on the Soroban testnet. Awesome. Let's take a look. More information on this smart contract. Let's take a look at the Explorer. And sure enough, okay? So what we can see is the contract address and the identity, aka the account that we used to deploy the smart contract, which is the account that I generated at the beginning of this video, okay? And now we have this smart contract deployed and ready for us to interact with, okay? Here's the fun part. We have to make calls to that smart contract. Then we can do calls through the Soroban CLI, but we also want to call this outside using JavaScript because we also want to interact with this from a front-end perspective, for example, or if you have an application that has been written in JavaScript, we need to also know how can we make those calls using a JavaScript environment, okay? So let's go ahead and do that. If I'm going to be working with a JavaScript environment, we have to install Node.js. We are navigating onto the node source Node.js binary distributions. This is the GitHub repo for Node.js distribution. And I am going to install Node.js 21, copy, and let's go ahead and paste, okay? Boom. Okay, done with the install. I am going to head to Visual Studio Code and let's work on the same folder, right? I'm going to make another folder called Soroban JS. Let's go ahead and create a file. Okay, this will be package JSON. What I'm going to do, I am going to be installing the Stellar SDK for JavaScript. Okay, so we have to install the Stellar SDK so then we have access to the interfaces that will allow me to make calls onto the blockchain from JavaScript. So then I can interact with the Soroban smart contracts. I'm going to go ahead and just provide the version here and we can just do an npm I and we are done. Populate the info here. I'm going to Control S. So basically we are installing Stellar SDK. This is version as a type module. Now open the console to that machine. So now let me list and we should have that folder ready to go. We'll say cd Soroban JS ls and now we have that package JSON. I can go ahead and type npm I and install. Okay. Okay. So now we are done with the install. Now let's start writing. Okay. Inside the Soroban JS folder, I am going to create one file. This file is going to be called Soroban tools. Okay. So I'm going to say tools JS. Okay, so what I'm going to do first, I'm going to show you how we can generate an account in the Soroban testnet and we can fund the account similar as what we did with the Soroban CLI. We are going to be importing the key pair. Key pair is one of the modules that I have available in the Stellar SDK, and key pair, I can generate that wallet, okay, or that account. Key pair, there we go. We autocomplete. And now let's build a function that will allow me to create that account. Let's call this sync function generate account. First one is going to be, let's call this key pair. Okay, so the key pair has two values. The first one is going to be the secret key, aka the private key of that account. And then the other one is going to be the public, aka the account ID. Key pair, and then we specify random. Okay, this will just generate a random account. If I want to obtain the values, which we should want to, right? Let's obtain both the secret and obtain the public. Okay, so the public key and the secret. Okay, so I'm going to say secret equals KP secret. Okay, and now we should obtain that returned. And now we're going to say pub key, and we are going to also obtain public key. Okay, awesome. Let's just console log, and we are going to say secret and then pass that value. And then now let's do it again, but now it's going to be account or public key, doesn't matter. Then we pass the value of pub key. Initiate that a call. So let's just do node Soroban tools. And sure enough, we have the key and the account. So now let's grab this value because I am going to be also funding this account. So let's go ahead now. Let me go back. So what I can do, let me just create a new file. This will be .env, and let's call this public key and secret. Let me paste what we got. Now what we're going to do, I'm going to pass this here. Copy, boom. This will be the secret. And then now the pub key. In case we are going to use that, we have it here. Okay, beautiful. Now we have that. We have the values. Okay, so I don't need to run this again. So I'm just going to comment it because I am going to be publishing all this in the GitHub repo. Okay, let me now write a function that will fund that account. Okay, function, and let's say fund account. And this is a straightforward API call. So this will be a fetch to the faucet. We have to just do a post API request and send the public key as the attribute so then we can fund that account. Before we do that, I want to show you something. I can land on that block explorer and I'm going to show you that this wallet shows, or this account shows, to be not valid, or like there's nothing showing. The reason why is, as I mentioned at the beginning, if you don't have tokens on that account, it's not going to be active. Okay. Okay, so I'm going to change this to Testnet. I'm going to paste that account, press enter, and sure enough, not found. Let's fund it and let's go back and see what will happen. Okay, I am going to try, and we are going to say const response. Let's just do a normal fetch. Okay. And now we are passing the URL of the faucet, okay? Which is this one right here. So it's friendlybot.stellar.org. Then I can now pass the parameter. So we have to encode this and add the public key as the parameter. So then we can request those tokens. Okay, so I'm just going to do, it's going to be here, URI component. And now we pass the value. In this case, I will be passing process.env. We're going to say public. Okay, close the here, should be good. There we go. Awesome. So now we are going to then await, right? We're going to say await response JSON. Then we are going to console log and account funded. Okay, that means that if this happens, then that means that the account got funded. We want to catch in case it doesn't, right? So we're going to say catch, and we can just catch the exception, the error, console log, and we can say just error, the error itself. Okay, so we'll pass that. Okay, now everything looks good. Okay, so now let me go ahead and run it. Okay, so I'm going to say fund account and boom. Okay, so let's hit it up. Let's see what happens. Boom. Now the moment of truth. Let's go back to the block explorer and see if the account is live. Let me refresh. Ooh, look at that. Okay, awesome. So we have successfully funded the account. Now we have this new wallet that we can use to deploy smart contracts, to perform calls, to execute functions, whatever is the case. Okay. Now let me go back. Next thing that I'm going to do, let me comment this back, right? Now I'm going to make another file. This other file that I'm going to make, it's for me to build an interface that will allow me to call straight the Soroban CLI by calling the console. So I can make calls into the console, like if I was going straight into the machine and making this call right here. So I can say Soroban, specify what the command is going to be. I can also perform the same call from JavaScript, from a JavaScript environment. So I can do this. I can say Okay, I'm going to make a new file. I'm going to say interfaces, okay, because we're going to be using this on other files. So I might as well build an interface that we can import to other functions and take advantage of it. Okay, with that, I'm going to do promisify and exec. And now with this, I can make calls like if I was actually typing on the console, on the command line interface. Okay, so I have to do this now. I'm going to declare this, which is part of this library, execute promisify exe. Okay, with this, I can make calls straight into the shell or the command prompt, and I can specify the same thing as if I was making calls straight to the Soroban CLI. Now let's build that function that all I have to do is pass the commands, and then it's just going to do it for me. Okay, so this is for me to avoid doing the interface. I can reuse this one. Okay, I'm going to say let stdout await execute. And now we have to pass the command, but in this case, this is just going to be passed as an argument. So then I can reuse this function anywhere I like. Then I got to do, this is part of that coding that I got to do. I got to say stdio inherit. And now we're going to say return stdout. Okay. What this is going to do, it's going to capture or is going to log the output. If I did this from the CLI, from the command line or the shell, I applied the command, gave me all this, then we are capturing that in that variable so then I can use those values in the function if I want to, okay? So with that said, I am going to be building this, then I can export this, okay? So let me export this, export, and then we can specify exe. And that's it. Okay, so now I can bring that in my tools. Okay, so I'm going to say import exe from interfaces, and this has to be JS. Awesome. Now, next thing. Now, one thing that we can test this with is saving the account in the CLI, okay, in the Soroban CLI. If I go to my Soroban CLI, okay, I'm going to say back. If I do Soroban keys, and then I can say ls, those are the accounts that I have, the identities that I already stored. So let me store this new one, the new one that we created with JavaScript, okay? So I can store this and reuse that, okay? So I can use that new account, all right? So let's go and do that. So let's build that function, and the function is going to be async function store account, okay? We want to save that account. So let me take a look here. I'm going to see what the syntax is to save an account if I already have the secret, because we got the secret from the call that we did, right? So I'm going to say Soroban keys add, and let me do a help, okay? So if we do help, I can provide the option of secret key, but it's expecting to use the value that we pass under this variable in the environment. So inside Ubuntu, I have to store the private key first as an environment variable. So then once I pass this option, then stores whatever was defined inside this variable, okay? So I have to do that. But in order for me to do that, I can do it through the CLI, that's fine, but I want to take advantage of that function that we built so then I can see that it's working, okay? So let me go ahead and do that. I am going to build that function. So the first function is going to be let store secret, and now the secret is going to be, well, the function is going to be await exe. We're going to use that new function that I declared. I am going to be passing that command. So what the command is going to be, the command, this is only for Linux, right? It's going to be export. Then I can define the key. What was the name that Soroban CLI expects? This one right here. So let me copy that. We'll go back and let me do this. I'm going to paste. And now I can go ahead and pass the value, okay? So I can say this, and now we can pass the value. What value am I going to pass? From the environment, we're going to pass secret, okay? So I'm going to pass secret here. I'm going to say process env, and now we'll paste secret. And this should store that information on the environment. So as a matter of fact, I don't need to store this on a variable. I can just run this. Once that gets executed, then I want to add that on the Soroban CLI. So I'm going to say Soroban key. I'm now going to say add. And remember, we are going to provide secret key. Okay, let's go back. Let me show you. So if we type Soroban keys add, then I say help, I just need to tell that it's a secret key, and we already should have stored that secret key with this environment variable, which we did before this, okay? So I am going to grab that, and let's go back here. And yeah, now we should be good to run this. So I'm gonna say catch e just in case, And we're going to say console log error. Okay. And I can say here, just to be safe, I can say console log keys stored. Okay. Beautiful. So I'm going to say add, and then I'm going to type the name, and let's call this John. Okay. I'm just going to create another key that's going to be called John. Okay. So I'm going to now run it. Awesome. So now it looks good. So now let me say Soroban keys ls. There we go. We got John. Awesome. So now I can use the John account and make calls, deploy the contract, and call functions inside the contract, etc. Okay. So now next thing that I'm going to do. Remember the smart contract that we deploy. Now we are going to be building a function that will allow me to read that smart contract and obtain information from that smart contract, or send call to write or to execute a function. Okay. So let's do that. So I'm going to make another file. This time it's going to be called Soroban CLI JS. First of all, let's find the smart contract that we deployed. Let's grab the address, which we have. Okay. Let contract address, and paste the contract address here. This was the hello contract address. Now what I'm going to do is that I'm going to also import exe because we're going to use it here. Okay. Now I am going to say async function read contract. This is one way of doing it. This doesn't mean that is the only way. We are also going to be interacting natively with the Stellar SDK. So read contract, for now, we're going to do this. We're going to say try, and now inside try, we are going to execute that exe once again, but I want to obtain the output and store it. Okay, so I'm going to say output, and now we're going to say exe, and we can pass the command. Okay, so I'm going to say the command to interact with a contract is going to be Soroban invoke. Okay. Now we type ID and we say contract address. This is the address of the smart contract. We are invoking that smart contract. Now the next thing that I got to provide as an argument is going to be the source account that is going to make the call. And let's take the opportunity to use that John account. Okay. So we're going to use John, and now we have to provide the network. What the network is going to be, it's going to be the testnet, right? We're just providing this value, same as what we did in the CLI. And now we are passing now effectively the function. Okay, so the function, this will be, and you can see that I did a double dash, and now we can pass the function name. Okay, this is very different from the other arguments. This will be the actual function that we want to call into that smart contract. So if I go back onto the smart contract, we got to make sure that we call source lib and we call hello. Okay, so let me go back. Let's say calls testnet, and now we can say, let me see if I can, hopefully I'm not in the way. Okay, now we're going to say hello, right? And remember, it was asking us for an argument, and the argument is 2. So I have to pass that argument as well on the call. So I'm going to say hello, I'm going to say 2, and now we are going to say the name. I'm just going to type the name, a name. Let's do net to def. Okay, I'm going to save that, and now let's console log output. Okay. And let's catch just in case. And we're going to catch, and we're going to say e console log, and we are going to say error. And now we're going to pass e just in case. Okay. Now we have this. We should be able to run this one. Read contract, and boom. All right. So let's give it a shot. We're going to execute Soroban calls. So I'm going to say contract and now invoke. So it's Soroban contract invoke. Pass ID, then provide the contract address, source account, then the account that I'm going to be using from my identity list, the networks, the testnet, and the actual function inside the contract. Then we pass the arguments. Okay, the arguments just going to be 2, and then the name that I want to pass. Okay, so we do that, and it's pending. So it's pending. That means that it's awaiting for that. So let me just do this. I'm going to say await, and let's see. That should do it. Let's wait for that. Woohoo! Hello, net to def. So that's what we are expecting. That was the function. The function is providing back, is returning hello, then whatever argument we passed. Okay, so we know that it's working. Now what I got to do, we are going to be using the Stellar SDK to make the same function. Instead of us using this console, we're going to be using the Stellar SDK. So with that said, I am going to build that function. Okay, and we're going to go and break it step by step. Okay, so we are going to take advantage of the interface, so then we can also export that function as we are writing it. Okay, so what we're going to do, we're going to apply it down here. We're going to say async function, and this function, let's call this contract interface, right? This function is going to allow me to send calls using the Stellar SDK. I have to bring a couple of dependencies, right? I have to import those dependencies. This will be from the Stellar SDK. And let me go ahead and paste it. I'm going to read it to you. Okay, so the first function, it's going to involve contract. This is the class that allows me to interact with the contract itself. I can do calls and I can pass the arguments like the function name and then the values and so forth. And we should be able to interact with the contract. Soroban RPC, this allows me to build that interface that communicates with the Soroban RPC. I have a transaction builder, networks, base fee, and the key pair. So contract interface, all right? So let's do contract interface. So in order for me to interact with the contract interface, we're going to say constant key pair. So we are going to be working with that key pair because I have to pass those values onto the call. So the first thing I'm going to do, I'm going to say await. It's going to be key pair from secret, right? And now I have to pass the secret. So in my case, I can pass process env secret because this is already stored in the environment, right? I want to use key pair, so this is uppercase. Now from here, I can obtain the public key because I have to pass the public key of the caller, okay? So I'm gonna now obtain that key from here. I'm gonna say constant, we're going to say caller, and now we are going to say key, and I'm going to obtain that public key. This is how we obtain the public key, and we did that previously. Now I'm going to define the provider. This is kind of similar to what we do in Ethereum or EVM-based blockchains, where we specify the provider, then we call that RPC address. This is where we're going to do that. We're going to define a new constructor. It's going to be Soroban RPC. Now it's going to be dot server. And now we have to pass the RPC URL. The RPC URL will be your Soroban RPC address. So I have it right here. So I'm just going to do this RPC URL. And now we're going to pass that address here. Okay. And now we are going to pass that down here on the server RPC URL. That's the first parameter that I got to provide. And we're just going to say allow HTTP. So allow HTTP. We're going to pass the Boolean value of true. Okay, cool. Now we are going to specify the source account that is going to make that call. Again, this is very similar to Signer. It's kind of similar, okay? Provider. Now we are going to get account, and we are passing the public key, which is defined right here, okay? So we're going to pass that as caller, and we're good here, okay? Now let's build that contract interface, very similar to Ethers. So on Soroban, you have a contract interface, very similar to Ethers. Then I can do call, then I can pass the function name. The difference is that in Ethers, I have to invoke the API, that is the JSON formatted file that has all the functions, so that I can call that function in particular. Here, I do not. I just need to provide the string value of that function and the values that I'm going to be passing as argument. That's it, okay? I'm going to say constant contract, new contract, right? And now we pass the contract address. So we got the contract address, which we did here. So let me just grab this address, copy it. I'm going to use it here in the interfaces, right? So I'm just going to take the opportunity to declare it here. Now we're going to pass contract address. And that's it, okay? So now we have the contract, okay? We have to do three things in order for us to interact with the smart contract. The first one is what? We have to build the transaction. So when we build a signed transaction on on any EVM blockchain, that we have to provide those parameters beforehand, then we have to wrap this onto a variable, and we can call this transaction. Then we can execute that transaction by first signing, then sending it to the blockchain, and so forth. Here is very similar. I'm gonna say let build TX. I'm gonna just build that transaction, and we are going to be providing the following. New, now we are going to be interacting with this one, this module, transaction builder. This is this class, which I'm going to be passing down here. Now I am going to be specifying the quote, the signer, which is source account, right? And next thing that I got to provide is going to be parameters. Okay, so I'm just going to declare this parameters. Now we have to start defining the calls inside this class. So I'm passing the transaction builder. We're building that class, so then we can start invoking the functions below that class. So I'm going to say now, first one is going to be add operation. Let me just throw it down below here, right? We're going to say add operation, and inside add operation, we are going to call the smart contract. This is where we use that contract interface. And now we're going to say call, right? And now we have to specify the function name. Remember in the hello world smart contract, I'm going to pass hello. That was the function name. And then now as the arguments, I have to pass the 2, but I don't pass the 2 like I did in the Soroban CLI when we did Soroban Contract invoke. In this case, I only need to pass the value because it's smart enough to know that the first value in that function is 2, which is the argument name. But this is expected to be encoded, XDR. This is the Soroban format that is expected to be encoded. We have to encode it here so then we can send it to the blockchain. How can we do that? We are going to be encoding a string or a symbol. If I am working with symbols, if this smart contract is expecting a symbol type, then I have to make sure that I convert that before I send it, okay? And this will be an array that I have to spread, so then I send those values individually. It's going to make sense once I write it, okay? Let me check what the value is. It's going to be a symbol, which means that I have to make sure that I send that attribute as a symbol as well. So let me write a function that allows me to encode those values on the fly. So I'm going to say networks, and in here, there is native to scval. Okay, so if we go back and hover here, this took me a while to get my head around and understand what was happening, but it's expecting this to be encoded in XDR scval. Okay, so I have to make sure that I encode that, and I can use this to encode that. Okay, so let me do that function beforehand. So I'm going to say constant, I can say constant, I'm going to say string to symbol. Okay, now I can pass that value. So what I'm going to do, I am going to be calling this, so every time that I need to convert string value to symbol so that it gets encoded in what the contract call is expecting, I can pass this value. Okay, so now I can say return, right? And we can say native to scval. Okay, now we're going to pass value. This will be the value as a string. And I am going to define this type right here, okay, as the options. I'm going to say type, and now we are specifying to be symbol, lowercase, all lowercase, okay? That's it. That should be it, okay? Let's say I need to also convert this onto unsigned integers, right? So I can make another function. It's going to be number to uint, right? So let's say 64. I'm going to say to u64, right? And now we keep this, but then now here we have to say u64. You see where I'm going, right? So now I have this function that allows me to convert this on the fly if I need to. So in my case, it's expecting 2, but I don't need to provide the argument that specifies 2. It's smart enough that to know that the next thing that it's expecting is going to be the first argument. I have 2. So environment is by default, then the 2 is the next one, okay? So it should be good. So let me go back here. Now we're going to say hello, and now we pass those values. But we have to make sure that we pass this as an array because it's expecting the array. I got to spread the array just in case I am going to be passing many functions, many values, okay, I should say. You know what? I'm going to declare this here, values, right? And just declare this inside here. So I am only going to be passing 1 because it's only expecting 1. So I'm going to say let 2. I'm going to say 2, and then I'm going to say the name, and let's say net to def, okay? Let's pass the same thing as we did with the CLI. But now I am going to be converting that to symbol, right? So I have to take opportunity and convert this value to symbol by enclosing it here, right? And now we have 2. Now I can pass 2 inside here, right? And now I can use values, pass it down here. But then I have to spread that array and pass it as the operation. The next thing, I'm going to add another item. It's going to be set timeout. For some reason, we have to set a timeout just to make sure that we await enough time before we can continue. And now we invoke build. This is literally how we wrap this transaction. We build that quote envelope. It's like an envelope, like for me to wrap all the call into that transaction. When we build that transaction like this, now we have this variable. Now the next thing that I got to do, I'm going to say let prepare tx. Now this time we are going to be sending this transaction to the provider. So we have to wrap the transaction, the build, and prepare that onto another envelope that stores what the transaction is going to be onto another envelope that will be sent to the RPC. Okay, so I have to send this to the RPC. The RPC quotes opens it and processes the transaction. So I'm going to say new, and then I'm going to say await provider, and we are going to invoke prepare transaction, and we pass build tx. So this is how we build that transaction, and this is where we sign it actually. Now we can say prepare transaction, and now let's sign it. This part here is very similar to EVM. And now we have to provide the key pair because we have to sign it with a key pair. This is like in EVM when we create a signer. This is the same thing. We create a signer. Now it's time to send that transaction to the blockchain. Okay, so I'm going to say try. I'm going to say let send tx. Let's invoke that. Await provider, and we can send that transaction. Okay, cool. And we prepare that tx already beforehand, right? So we're just passing it and just catch if there's something going on. Okay, so I'm going to say function error, function callback, and then just, return me error, right? Just in case it doesn't work. Let's just close it. That should do it. Okay, awesome. Now wait for this to process, right? And then we are going to run a while loop that the moment the transaction has been successfully confirmed, then we return the output. That tells us that we were able to write on the blockchain and the transaction was successfully submitted, processed. Then all we have to do is clap our hands. Okay. So I'm going to say send tx error result. So this is something that will be turned in case there's an error. Okay. So this is the value that we should obtain in the output when it runs in case there's an error. Okay. And I'm just going to throw that in the execution. I'm going to say new, I'm going to say error, and then we're passing the message, unable to send tx or something like that. Now, if that doesn't happen, now we're going to say it once again, send tx status, and we are going to say that if it's pending, right? If the status of that transaction is pending, that means that it was successful. Okay. We are now going to obtain an attribute that will tell us that the transaction was successfully completed. But as we wait for that, because we don't know, this will be up to the blockchain to process it, right? So once the ledger gets the transaction, gets executed, gets confirmed, we should obtain the output. And then that tells us, yes, it's successful, but we have to keep checking. So that will be the while loop that I'm going to be writing here. Let tx response await provider get transaction. So this is me to listen for that event, right? So we are calling the provider get transaction, and we are passing send tx, and inside this return, this promise that gets fulfilled, I should have key. Okay. So we pass that and we check and see if the transaction got completed. And this will involve that loop that I was talking about. While tx response status shows not found, that means that it hasn't been picked up by the validator, which means it's not found. Tx response, I'm going to update that state saying await provider. Once again, we're going to call that provider. We're going to check again, send tx hash. We're going to check once again, but this will be inside a while loop. So I'm going to check once again, and I want to run that while, but by updating this tx response, because this is a let, this mutates, I can update that. So that means that every time that the while runs, it's going to recheck once again. And if this changes, then this no longer applies and I can move forward, right? So this is a great way for me to validate the transaction on the blockchain. I'm going to say now await new, I'm just going to make a sleep. So I'm going to sleep and recheck every X amount of time so that we're not overwhelming the RPC. So the promise, now we're going to say resolve, and we're going to say set timeout, and we are just going to repass this. This is a very simple sleep in JavaScript, which basically just fulfills and 100 milliseconds retries again, okay? And that means that if this no longer shows not found, because every time that I run this while loop, it checks and updates the response. If it changes, then we're effectively doing something else. Tx response status, now success, that means that the status was successfully updated because now we got validation. We are going to return back promise, okay? Let result, and we just pass whatever value we obtain. Return value. So this will be another parameter inside of this tx response that we can call. This will obtain the data. So if we call this function to read, then this should encode that data that we're looking for, okay? And this also can be used to write. So this will be write and read, okay? Return, and we are returning that result. Beautiful. So this is the function to write to the Soroban Smart Contract, but it has everything. You can read, you can write, and so forth, okay? Now I am going to, I gotta provide that catch in case, catch, let's say E, just in case something happened, an error or something, okay? So now we have this contract interface, and I can export that contract and pass the arguments, right? So I am passing the contract address, and I have to pass the function itself. So what I can do, I am going to take opportunity and use this function across my environment. So I'm going to say function name, and then we can just pass arguments. I can then export this and use it somewhere else and so forth. So I'm going to say function name, right? And I should be able to also pass the values. As a matter of fact, I'm going to do it. So then this is strictly to make calls to the blockchain, to the smart contract. Okay, I'm gonna bring Soroban calls here, and then I'm gonna prepare that function right here. Async function read contract B. So we have another, we have this function done using the CLI, but then this one is done natively with the Soroban, the Stellar SDK. And now we can provide those values once again. Now I have to pass my functions that I created to convert this. So I'm going to say, grab this, and then let's go to calls. Let me define this here, which also means that I have to bring those interfaces or those modules here. So I'm going to say native to SCC val. Okay, so that's good. Okay, now I can use it here. I can now convert, and I can pass values. So now let me export that interface, contract interface. I'm going to export it here. So we exported the contract interface. What else do I have to pass? I have to pass the values, obviously. Okay, because I will be sending that here. Well, that looks good. I think that's it. Everything else is contained here. Now I have to define parameters. Parameters, it's the options inside that RPC call. So I'm going to say let params, and now we can define them here. Now we're going to say fee, and now we're passing base fee. Remember, we call this. So we're going to pass base fee. This is the fee that is expected to be paid to execute that transaction. Now we're going to say network passphrase, and this will be networks. So we are using networks, which we also imported from the SDK. And we are going to say testnet. Okay, so this is how we pass the passphrase. This is already included in the SDK. And that's it. Those are the two items. Okay, so we got values, function name. Awesome. So let's continue here. So we are now going to import that contract interface. Cool. Now let's go down here. I'm going to say values 2, and now we can say let result. And now we are going to await and call that contract interface. Now we pass the function name. Let's just define the function name here. It's going to be hello. And then we are passing the values, okay, which we first encode and then we RFI, pass it here. Okay. Now if we console log result, I wonder if it's going to work. Let's do that. I'm going to say, by the way, this is going to be recontract A. I'm going to grab this, put it here. And now it looks more clean, right? So this is like very clean. Okay, so we're going to recontract B, and hopefully no errors. So let's go back. Okay, node Soroban calls. Let's see how that goes. Okay, so we have received the return. What you can see here, this is the raw output that we received from the Soroban Smart Contract. I have to export value. So I have to filter the output to show me value. Those two shall union keys inside this array, right? This value, it's the actual data that we are looking to receive from that function. So what I'm going to do, I am going to filter the output. I am going to export value, and then we have to convert this into string. By converting the value to string, we will obtain the actual string value. So let's go ahead and do that. I can see that value, we have to export value. So we'll export value, then we'll have to export value again. We have an array, there's two shall unions inside that array. So I have to export this one, then this one. Okay, so it's very straightforward. So now let me export the first one. So I'm going to say result underscore value. Okay, and then if I do this, I should be obtaining the first object inside the array. So let me do this, call it again. And sure enough, I have the first one. So now if I convert this to string, I should be obtaining the first value. Now we're going to say the underscore value. What I'm going to do, I am going to close this and then say to string. And if we do that, we should receive the first string value that we obtain from that smart contract. So if we go to the smart contract, it's going to be the first one, hello. Then 2 will be the value that we pass when we make the call. So let me show you back. The call that we're passing, it's net to dev. We are converting it to scval. So I'm passing it here. Then this should give me 0, should give me hello. Then the next one should give me net to dev. Okay, so I'm going to control S, go back, try it again. Hello, awesome. Okay, now let's do the same for the second one. I can do the second one here. And this time I'm just going to do 1, give it a shot again. Hello, net to dev. Awesome. Awesome, awesome. I am sending this right here, value. So if I'm passing my own value, that means that the smart contract is receiving that value and it's able to send it back to me. So that means that I know that it's working, okay? We have completed making calls to a Soroban smart contract using JavaScript. On the next and final video, what I'm going to do, we are going to be deploying the vote smart contract. We will also build those functions and make calls to that vote smart contract to store data, to retrieve data, and to see a live application that will allow users to vote. So on the next and final video, we are going to create a very simple front end, and we will connect the vote smart contract that we wrote in the first video, and we will make calls into that smart contract using the Stellar SDK. Alrighty, that's it for this video. If you enjoyed this tutorial, give it a thumbs up. Subscribe if you haven't subscribed too. Hey, and we'll see you on the next video. Bye.